When wiring a mobile home service of 100 amps with a 200 amp service pole that has a 200 amp main breaker, and the mobile home panel has a 100 amp main breaker, a 100 amp breaker is required at each end of the service feeding the mobile home because the service wire is protected by both the 200 amp main breaker, the service pole, which acts as the main disconnect, and the 100 amp breaker in the home, which acts as the overcurrent protection for the wire size. This dual protection ensures that the wire is not overloaded and that the circuit is properly protected. The 200 amp breaker, the service pole, protects the entire service from the utility transformer to the mobile home panel, while the 100 amp breaker in the mobile home protects the wiring within the mobile home from overcurrent. This arrangement provides a coordinated protection scheme. The 200 amp breaker protects the entire service and the 100 amp breaker protects the branch circuit. If the mobile home were to draw more than 100 amps, the 100 amp breaker in the mobile home would trip, protecting the wiring in the mobile home. If there were a fault on the service conductors between the service pole and the mobile home, the 200 amp breaker at the service pole would trip, protecting the service conductors. This arrangement of breakers is necessary to ensure the safety of the installation. It's important to use appropriately sized conductors for the load and to properly protect the conductors from overcurrent. Conductors should be sized based on the ampacity of the load, and overcurrent protection should be provided to protect the conductors from overload and short-circuit conditions. The National Electrical Code, or NEC, provides guidance on the proper sizing of conductors and overcurrent protection. The NEC provides specific requirements for mobile home services, including the sizing of conductors and overcurrent protection. These requirements are designed to ensure the safety of the installation. The overcurrent protection device is typically a circuit breaker or a fuse. The overcurrent protection device should be sized to protect the conductors from overload and short-circuit conditions. The NEC provides tables that specify the maximum overcurrent protection for different sizes of conductors. When installing a mobile home service, it is important to follow all applicable codes and standards. This will ensure that the installation is safe and compliant with local regulations. Now, regarding electrical panels inside homes wired with as many as 20 breakers installed without a main breaker, the assertion that the code states no more than 6 switches in a panel without a main breaker is incorrect. The National Electrical Code does not limit the number of breakers in a panel without a main breaker to 6. The NEC requires that all panels have a main breaker or other overcurrent protective device. This is to ensure that the panel is properly protected and that the circuit is not overloaded. The main breaker provides overcurrent protection for the entire panel. If the total load on the panel exceeds the rating of the main breaker will trip, protecting the panel and the branch circuits from overload. The main breaker also provides a means of disconnecting power to the entire panel. This is useful for maintenance and repair purposes. The overcurrent protective device can be a circuit breaker or a set of fuses. If the panel does not have a main breaker, it must have another overcurrent protective device that protects the entire panel. This overcurrent protective device must be located at the point where the conductors enter the panel. The NEC does have a 6 disconnect rule which applies to service equipment in some situations. This rule states that the service disconnecting means must consist of no more than 6 switches or circuit breakers. However, this rule does not apply to branch circuit panels inside homes. Branch circuit panels are required to have a main breaker or other overcurrent protective device. The size of the main breaker or overcurrent protective device should be based on the ampacity of the service conductors. The service conductors are the conductors that connect the service equipment to the utility power supply. The ampacity of the service conductors should be large enough to carry the total load of the panel. The NEC provides tables that specify the ampacity of different sizes of conductors. When installing an electrical panel, it is important to follow all applicable codes and standards. This will ensure that the installation is safe and compliant with local regulations. It is also important to use qualified electricians for all electrical work. Qualified electricians are trained and experienced in electrical work. They are familiar with the NEC and other applicable codes and standards. Qualified electricians can ensure that electrical installations are safe and compliant. To reiterate, the NEC doesn't restrict panels without main breakers to just 6 switches. The requirement is for overcurrent protection. The main breaker or overcurrent device safeguards the entire panel from overloads and facilitates a way to disconnect the panel. Proper conductor sizing, adhering to ampacity ratings, is crucial to prevent overheating and fire hazards. The NEC tables are used to determine the correct conductor sizes based on anticipated loads. Overcurrent protection, usually via circuit breakers or fuses, must be installed. The selection depends on the conductor size, with NEC tables providing guidance. The 6 disconnect rule is about service equipment disconnecting means, not branch circuit panels inside homes. These must have a main breaker or equivalent overcurrent protection.